Hello and welcome to the second lecture of the network security course. In this lecture, I'm going to be talking about access controls. Okay, here are the references for this lecture, and we're just going to go and start defining access controls. So we talked last lecture about assets. Assets are anything that need to be protected and has a value to the organization. That includes data, but also includes any physical devices, servers, computers, switches, routers, anything. So access controls are the methods or the measures that are implemented to restrict access to these resources, to these assets, to only users or programs that are authorized to use them. So the access controls in general define the users, who are the users, define what users can do, for example, read or write in a file, what resources the users can reach, can access, and what kind of operations. So these are the 3 or 4 different things that the access controls define. And when we talk about access control, we talk about many technologies that are under this umbrella. So we're going to talk about all of these in this lecture. If you classify access controls broadly, you may classify them into physical and logical access controls. The physical controls, like a door or a lock, something physical that restrict access to the resource. So if you have a server room, for example, you probably want to have a door and a lock, so that only authorized people can access the server for maintenance or for repair or for replacement, etc. Right? Logical access controls are probably a category that includes a lot of things, including, for example, passwords. We use passwords as access control to many resources. So we probably will focus most of the conversation in this lecture about logical controls. So logical controls decide which users can get into the resource, the system, or the asset in general. They monitor what the users can do, and if necessary, enforce policies on those users. Right. So in the slide talks about HR employees can reach sensitive information related to, let's say, salaries of employees. Right. The employee can view the salaries, can maybe edit the salary if the employee get a raise, for example. But also access controls, logical controls is supposed to prevent users from abusing their authority. So if somebody is making changes that they're not allowed to do, probably the access controls will be used to maybe deny access for the system in the future, or demote the access, instead of editing, become only view. So we're going to talk about the elements of access control. First thing, to the right hand side of this slide, you see object. The object is the asset, is the entity that contains information or something that needs to be protected, right? The object can be a computer, a database, or part of a database, a file, or a whole hard drive, anything that needs to be protected. The subject is the user or the program or a process. So we're not, probably I'll mention user most of the time, but really the subject can be a person, or it can be a program. A program or an app can be the subject in the system, and it needs access to a resource, to a file. So the subject is a general term that includes all of the entities that need to access the object. Then we have the relationships. The relationships are the permissions granted to the subject, right? So the subject may read the file, write to a file, delete a file, move it. All of these needs to be specified as permissions, what the subject can do, right? The actions are the activities that the subject actually doing or performing on the object, on the resource. So these are the elements, and you can see here there are more. So we have the security kernel database and the access control list and the audit log. So what are these? So the security kernel is the actual part that manages all of these activities, or monitors access to the subject, or moderate, I should say, moderate or mediate all access requests, and check if the subject has the permissions to do the activities that they are planning to do. So if the subject wants to delete a file, the kernel will check if the subject has the permission to delete file, and if the permission is there, so the activity is allowed. If not, the activity is denied, right? And so on for all the permissions. So the kernel is the control, right? Or the central control of the system. The access control policies are the rules that allow the users to perform a particular set. So the kernel probably will rely on access controls to tell it what the user can do and cannot do. And finally, there is the audit log here. There is no slide for it, but we are supposed to maintain accountability for all the actions. So we need to log everything, right? So if the subject read a file, we probably need to log that reading. If the subject deletes a file, we need to record the deletion so we can go back and do an audit and say, well, were you allowed to do all of these things? And if not, then probably we have to take actions, or the system has to take actions. Okay, so if you think about all of this, you'll see that the access control has two parts, two phases and four parts. The policy definition phase and the policy enforcement phase. So the policy definition phase usually comes from people. This phase determines who has access and what systems or resources they can use. This is not determined by a computer. This is determined by the organization, determined by people. Right? If you are the CEO of a company, you are allowed to sign contracts on behalf of the if you are a CEO of a company, you are allowed to sign contracts on behalf of the company. But any other employee doesn't have this authority. So this authority comes from the role of the CEO, or the role of the chief financial officer, or the role of the chief operations officer, right? So these are the authorization given by the organization. The policy enforcement phase includes identifying the users, identifying the subject, authenticating them, and finally the accountability. So each one of these, we'll talk about it in detail. So if I want to summarize the four parts, the authorization determines who is approved for access and what they can access. Identification determines who are or how they are identified, so the method of identifying or IDing the user. Authentication determines how can their identities be verified. So it's not enough that I can say I am the CEO. Somebody has to verify that I'm actually the CEO of the company, right? And finally, we need to trace the action, so we need to maintain accountability. So as I mentioned, the authorization is the process of deciding who has access to which resource. They usually based on job roles or um, experience or any other requirements, either by a company or by a government. Um, Authorization sometimes happen at individual level. So there is one CEO, so that one CEO doesn't have any other CEO, so we can tailor some authorization based on that particular person. In many cases, we cannot just go to each employee of an organization and give them a specific authorization. That's too much work and very detailed and require a lot of administration effort. So we may group them into groups. Let's say all the accountant or all the members of the accounting team, they have similar authorization. So that's a group membership, right? So we determine policies based on groups. All programmers, they have similar authorizations to access certain resources. So we can develop our authorization policy based on groups and so on, right? So we can do it by individuals, we can do it by roles, we can do it by just being a member of a department or an employee of a department. So we'll talk about these systems later on. The second part is the identifications. So how do we identify the user, whether it's actual person or a process or any other entity? For people, usually we identify them using a username. When you log into your bank account, you need username, or in some cases, you need your bank card number. So that's a unique method to identify you. A PIN sometimes is used. Any unique ID method. Um, Sometimes physically you need a smart card. As long as you are carrying that card with you, that card provides information about you. Probably if you are a student, you will have your student ID card that you carry with you. You can open doors, you can use it to attend exams, you can sometimes pay with it. So that card will be your identification method. And another identification method is biometrics. These are physical traits like fingerprints or DNA or retina scans. These are something inherent or intrinsic to you that you can use to identify you. Usually, identification methods, they must be unique, right? We can't have two persons with the same ID. That will just confuse the system or allow those two users to be interchangeable in the system, which we cannot do. So we have to have unique ID. The unique ID also must be non-descriptive. So you may have a username that's part of your name, all right? So the first letters of your first name and the first letters of or first three letters of your last name. So you can mix um, things to create a unique ID for the user, but it can't be CEO 123 or admin 456. That's too descriptive, right? So that indicates who the user is, and the problem with being descriptive or that obvious is that people can guess it, right? A hacker can use this, can guess the user name and use it to identify themselves. Also, the identification methods must be provided and also disabled or revoked by an authority. Who gives you the or who gives the user the ID must be some authority in the organization. Okay, so IDing a user is one part, but then we have to verify that the actual user who provided the ID is the real ones. They're not pretending, right? So authentication usually deals with who they or making sure that the users are what they say they are, right? So we want to make sure that they're not imposters. So we need to have authentication methods. The common authentication methods, there are three, and I split the screen here into two groups. The top ones are common ones, and most resources, most references mention the top three, and there are more actually at the bottom there. So what are the top three? We can classify authentication types in three categories: things that you know, or something you know, which based on knowledge or based on memory, something that you remember, right? Password or a PIN number. Usually you or the user remember this, and when they try to access the system, they supply their identification, which is probably a password, a username, and then they provide a password or passphrase. So that's require memory. Another thing or another type is ownership, or something you have, something that you carry with you. A smart card, a key, token. That's something you have to carry with you. You don't have to remember, but you have to carry with you to supply every time the system needs authentication. And finally, something we call something you are. Something you are is attribute unique to the user, right? Fingerprints, it usually cannot be replicated, hardly replicated, or never replicated by anyone. Retina, uh, I'm gonna remove the signature there, so the signature is actually supposed to be in the bottom one. So fingerprints or retina, something that it's intrinsic to you, right? To the user. So these are easily remembered by something you know, something you have, something you are. Some of these can be used both in identification and in authentication. Notice that I mentioned PIN as a way to provide um, identification, and here we are using it as authentication as well. Another thing is the characteristic. The biometrics has the ability to both identify you and authenticate you, right? So you can just go to a system and provide your fingerprints, and that will be it, right? Um, so some of these can be used as both identification and authentication. All right, so let's move on to the bottom four. The bottom four, there is the action or performance, and you can remember it by something you do. So when you um, write a signature, that's something you do, right? And signature it's not impossible to reproduce, but it's hard for people to reproduce easily, so that can be used as authentication way. If you are looking at these slides, you probably should remove or should ignore the signature here. It's supposed to be in the action or performance. Behavior. Everybody has certain behavioral uh, traits that they do without being conscious about it, right? The way you walk, the way you talk, the way you like there is moving your hands when you speak, um, gestures. You can notice that I have a certain talking pattern here. So these are the things that can be used to authenticate you, right? So this is something you exhibit. Locations. Another authentication type is the actual physical location. If you are trying to open a door for a lab, for example, right, and maybe the door can be opened remotely by sending a command to the lock from far away, right? But if you add the location, then the system will not allow the user to open the lock unless they are actually physically at the same location as the lock itself. So they guarantee that the user is present in front of the door. So that's a location authentication type. And you can mix these, by the way. I'm going to talk about this in the next slide. Finally, relationship. So a trusted individual, the user have a relationship with. The example that I can think of right now is, let's say you go to a secure location, secure organization, right? They don't know you, you are a guest, so you don't have an authority to go and walk around. But uh, because you are a guest and you probably need to have a meeting there or you need to have a visit for a legitimate reason, they assign you an escort. Somebody comes to meet you at the door and walks with you, right? So it happens in many cases in secure locations. So somebody, an employee, um, comes and escort the visitor, right? So that's an example of trust by an association. As long as you are with that person, well, you are okay to go around and walk around, and we trust that person who is escorting you will not take you to a location where you're not supposed to go, right? So that's the final one, which is someone you know. So you can um, remember these things by something you know, something you have, something you are. These are the main three. And then something you do, something you exhibit, something you are, something you know, or someone you know. So these authentication types can be mixed. So if we use one of them, just password, for example, we call that single factor authentication, right? So one type and that's it. The one type can be easily compromised by today's systems. Passwords can be cracked. Uh, PIN numbers can be guessed. We consider these too weak for today's environment. So many systems right now moving to something called two-factor authentication, which means you are picking two of the previous um, seven or three or the top three. So you may need to have a username, a password, and maybe a badge, right? Or a password and retina scan, any two. We call that two-factor authentication. If we go beyond that, we call it multi-factor authentication, which is multiple techniques. Okay, so in the previous examples, I mentioned people, like people can have a retina scan, people can have fingerprints, people can sign. What about systems? Because the users or the subject in general terms are not just persons, they are sometimes programs. So the systems needs to be authenticated as well. Okay, so systems can be authenticated by their MAC address, by their IP address. So that's supposed to be unique to the system. But we also know that these things can be compromised or it can be changed. So we may need other techniques like tokens, for example, a hash number that we use specifically to authenticate a program. So there are many techniques to authenticate programs. Okay, let's talk about the three main authentication techniques, something you know, something you have, something you are. So we talked about passwords as one of the main and common way to authenticate. So passwords are considered the weakest, even though they are the most common. Weak before because we can use brute force, as you know, that we can just because systems right now, computers are so fast, they can just continue use many combinations until they find the right one of the right combination of characters and numbers and all of that, so that they can guess passwords fast enough. So we can make the passwords more difficult by increasing the size of the password. The longer the higher the number of characters and numbers and special characters in a password, the harder for any system to find the password by brute force. And also, um, so that's why many systems right now and system administrators insist that we have at least 8 alphanumeric characters, so that's letters and numbers, and sometimes we insist that the numbers or the characters have to be uppercase and lowercase in case of English. Also special characters like exclamation mark or hash. So the more variations, the better. And you know from cryptography that if we have 8 characters, so we need and we use only English letters, and then the number of possibilities are 26 to the power 8, right? Um, that's if we can repeat the characters, right? So we have, for example, um, we can have 26 different. So the first character, just a reminder, the first character there are 26 possible ways to pick from A to Z, right? And then the second character also can be anywhere from A to Z and so on up to 8 characters. So if you multiply all of this, you will find that the number of possible ways you generate 8 characters from English characters, 8 letter password from English characters is 26 to the power 8. Now, if we add numbers, so we have 26 letters plus 10 numbers, so now we have 36 possible um, characters we can use. So we increase the difficulty and now becomes 36 to the power 8. If you add upper and lower, so that's 26 plus 26. So you see that the more characters we have, the more difficult for any system to guess or to actually find the password by just brute force by trying all the combinations, right? So that's why we need to increase the the, the size of the password and make different combinations. All right. Um, so these are the common at least 8 alphanumeric characters, a combination of uppercase and lowercase, at least one special characters. These are common things that the administrators ask for. Um, the password must have a letter to begin, like it starts with a letter. Don't put a username in the password, so don't use your username as password or part of a password. Don't put the name of the user. Don't put any ID in the password. So basically, all of these things will attempt to reduce the guessing, reduce the possibility of a hacker guessing the password. Right? Don't use any common English dictionary in case of English, so don't use something that uh, you can find in the dictionary, a word that people use. So these are the common. Now this is just an example, right? So different systems require you different criteria for passwords, but these are the common ways you make sure that the password is strong, right? All right, but the problem with these, and probably you notice this when you use different systems, that the more the system asks you for these things, the more harder for you, or the harder for you to remember the password. So you can remember, password 123, right? You can remember this. But if you start doing hash 3M6WR, so you cannot remember this password, right? And it becomes difficult for people to remember the password, and this is one of the reasons people actually use weak passwords, because they try to use a password that they can remember, right? Nobody can remember 12 characters of mix and upper and lower and special characters and all of that. So people tend to use weak passwords. All right, so there is a somewhat a solution for that, which is a passphrase. A passphrase generally is longer than a regular password. So instead of just 8 characters, you may take 20 characters. But usually it's a phrase that a person remembers. So let's give an example. I am a Dell student, right? So that's your phrase that you use as a password, right? All of this, of course, breaks all the rules. There are no numbers in this. There are no upper and lower characters, just a phrase. But the phrase is long enough that it's hard for people or systems to guess it. So it has a unique meaning, right? I love cats, right? So something unique that you can always remember. You can make it more difficult, or you can actually um, one way to make it more difficult is to change the O's into zeros, change the I's into exclamation marks, change the E's into three. So you mix or you change some of the characters. You still remember it. You still remember I am a Dell student, right? But when you write it instead of, let's say, as I am a Dell student. All right, so there are a lot of I's here, so maybe I'll just do replace all the I's with at. Oh, A's, I mean, sorry. And S, maybe put it as $, STU. E, put it as 3. So that becomes a little bit more difficult for people to guess. You still remember it, I am a Dell student, but a little bit unusual because you change some of the characters. You may actually go and make things even more difficult by, instead of having ads everywhere, you can just change it to something else, put a hash tag, so instead of ads, so it makes it difficult for people to guess, but you still remember it easily, right? So every time you say, okay, the password is I am a Dell student, but then I need to make these changes. They are not as easily susceptible to brute force, even though they are actually words in English. You can remember it, but they're not easy to brute force because they are longer. And if they are longer, it's first of all, every password has a different length, so the attacker doesn't know, is it 8 characters, is it 10, is it 12, and also if it's 8, it's still you have to go through 26 to the power of 8 at least, different attempts just to guess the 8 characters. And imagine if they are 20, so it's a little bit harder to guess and to crack using brute force. All right, so that's ways to authenticate by something you know. The other method is authentication by something you have, ownership. Now, this is a picture of a token that was popular at some point of time. Nowadays, everybody has a phone, cell phone, so you can replace this, or you can imagine your smartphone replacing this token. But the idea is the token is issued physically, right, to you. You can carry it with you all the time, and the token has these numbers that are generated randomly, and they change every minute. These lines here, you see that they go down, so you have at first 6 bars, so maybe you have 60 seconds to enter this number, and then they go 5, 4, and so on. By the time they go to 0, this number changes. So how it works, generally speaking, so there are different types, but generally speaking, you enter your you go to the client in this case, or the user, try to access a system. Right. So the login process includes username, so that's the ID. So the system here, the resource, will need something else, the authentication method. So the second, or the authentication method, this is the ID, right, which is the username, and then the authentication will be the number that was given in the token. Both the server, or the resource, and the token here are synchronized, and they are unique. The numbers are unique to the user. So the server looks at the username, says, okay, I know that this user has this specific token, and in this particular time, the number that I'm expecting is this one. So if I receive this number, I know that this is the actual user, and they are who they claim to be. If I'm receiving a different number, then they are not the correct user, and they're not going to allow access, right? So there are what we call asynchronous tokens, and there are synchronous tokens, which are either time-based or event-based. And finally, there is the continuous authentication. Right? So the top three are you do it one time only. Right? So once you log in one time, you provide the number and then that's it. With the continuous authentication, you're always authenticated. You're always have to be close to the system. So let's take a look at these in detail. So the asynchronous tokens using an algorithm that calculates the number at both the authentication server and the device, displays the number on the device screens, and the user enters this number along with the PIN or password, right? And I'll show you details later. In the time-based, the current time is used as the input value. So the number changes based on time. The number that you see in the token here changes every minute, as I said. So it depends on time. So it requires that there is synchronization, time synchronization between the server and the token. In the event, there is a counter instead of time. It's a counter, right? You log in the first time, that's a new number. Second time, the number changes, and so on. And finally, the continuous authentication is continuously validate the user. This means that the token has to be always close to the system that you need to access. If you move away, the system logs you out, right? This is another way of verification by location, by the way, like because it does the same, or authentication by location, which does the same thing as the person has to be close, and this is usually used in really highly restrictive environment, highly secure environment, if to prevent the user from forgetting to log out. A user works on a sensitive project, sitting in front of a computer, typing, viewing data, doing something, and then they move away, they go to the washroom, for example, and they forget to log out. So somebody else may come and sit down and view the information. So by having continuous authentication, as soon as the user moves away, the system logs you out. All right, but let's talk about the time synchronous tokens, right? So this is the flow of events. The client, the user has a token, and as I said, if you have nowadays, instead of physical token, everybody using their smartphone, so it's an app on a smartphone, right? So your smartphone has an app. You want to log in to a server, so you send a login request with your username. The server say, okay, give me the number that you have on your token or in your smartphone. At that time, at time 8 o'clock 21 and 0 seconds, 21 minutes and 0 seconds, both server and tokens generate the same random number, right? Because they are using the same algorithm, and the algorithm is synchronized in time. So they both generate the same random number. Here we're going to say this is Rn and this is Rn prime. So they are supposed to be the same, right? So the user looks at the token, looks at the number and enters this number into the system. The system compares the random number that generated locally with the random number that was entered by the user. If they are equal, then the access is granted. If they're not, then the access is denied. Right. So this system requires that the user and the server and the token are always synchronized in time. Now you see the problem here. If the server clock is out of sync with the token, you change something and then both are no longer synchronized, the algorithm generate two different random numbers, so the user won't be able to log in. So that's the weakness of the system, right? But we use this or this is a common way to synchronize nowadays. All right, the second one avoids this time problem by doing event, by instead of um, using actual time, we use the number of logins as a counter. So every time the user tries to log in, again sends a login request with a username, the server increments the number of logins. So let's say this is the login number 56 from the user, right? So increments the number of logins and generates a random number based on the 65th login, right? Say, okay, now give me your random number. The user also clicks on the token, increments the number, say this is a new login for me. So now she counts the 65 login as well. So both servers know and the client know that they are logging in for the 65th time. So both algorithms will generate the same random number. The user will enter this random number and they match and the access is granted. All right, so in this case, it doesn't require time synchronization. They just need to keep track of the number of logins each one. So the server always have the same login numbers as the client. This one also has a problem. The problem is, let's say the client, the user, logs in or request login. So the server says, okay, this is your 65th login. So I'm gonna generate a random number based on this. The client here says, oh, never mind, I don't want to log in now. I want to go somewhere else and come back later. So when they come back later, they will try to log in again. The system says, okay, this is your 66th attempt to log in. But the user, from their perspective, it's still the 65th because they didn't really increment the counter last time. They started the login process, but they didn't finish it. They didn't enter any random number. They went away. So now the two systems are not synchronized. The server thinks that it's the 66th attempt to log in, while the token has the 65th. So this one is also has a problem, right? To avoid both systems or the problems of these systems, we can use something called asynchronous token. The asynchronous token uses technique that you know from cryptography. It just sends a challenge. Both token and servers would use the same algorithm to generate to encrypt numbers and common keys in between, and there are no need to synchronization. So the user issues a login request, enters their username, the server sends a challenge. The challenge will be a random number, right? And the random number here, the user takes that random number and enter it in the app, or the if it's a token, there will be a special token where you can actually enter numbers. So you enter the token, or the user enters the challenge that came from the server, and also enters their unique PIN number as an extra measure of security. What the token does is actually encrypts this number and the PIN, so it encrypts both and generates an encrypted number here. The user enters this number. The server will decrypt the number that it received and if the number that it got after the decryption matches the number that it issued earlier, then it must be the unique, it must be the right user, the correct user, and access is granted, right? So this actually rely on one of the techniques that we saw in cryptography. So let me do a little bit of review here. So let's say you know from symmetric or private key symmetric cryptography or private key cryptography that both let's say both systems, the client and the server, they agree on one algorithm and one key, common key, right? So the the client puts a username, the server generates a random number and send it to the client. The client, now using this key and the common encryption algorithm, will encrypt the number and also adds part of the username or a PIN or something that the server already knows, right? So in our example, we use a PIN, right? And then, so it's a common concatenation. So we'll just put the number as a string and then add to it the PIN as another string. So you can have a string of two numbers there. And you send the encrypted string to the other side, to the server. The server will use the same key. So here is the key that we use for encryption. So use the same key to decrypt. So what happens is you get the same R and the PIN. The server knows that it sent this R and it has the PIN registered in a database, or it came during the login anyways. So now we know that this is the actual client. Why? Because they agreed on a key prior to that, right? So if it's a different client, will be a different key. So we may use actually different techniques. We may use private key cryptography, right? So both client and server agree on a common key during the registration process, for example. Or we may use public key cryptography, so the server will issue its public key for everyone to know, and then the client will use this public key to encrypt the information. So you can use different techniques, and we saw that in the cryptography course. All right, so these are different techniques. This doesn't require any synchronization, but it requires that the token and server has a common password, right? Or common key for encryption. There are other techniques as well. Sometimes we use smart card. Smart card has a chip. It carries information. The smart card, or this doesn't have any power source, but if you insert it in the card reader supply power to the chip and also will be able to read the information. So the information will be information about the user, your name, your ID, the status, faculty, student, what year you are as a student, what course you're taking, because you may have to access certain labs for certain courses. So any information that's needed in the smart card, right? You can also use USB as a token. So you want to access a certain application, you insert a USB, and the USB will have uses public key cryptography, for example, or a digital signature or something like that to authenticate. There are also cards with magnetic strips. You're probably familiar with those. So they have the magnetic strip, actually, it stores all the information. And when you swipe it the reader, you read, or the reader reads the information from the card. So all of these are techniques that the common among them is you have to carry them physically with you. If you don't have them, then you won't be able to authenticate. All right, so biometrics or authentication by characteristic is something that doesn't need memory, nor you need to carry anything with you. It's something that's built in, right? So examples: fingerprints, palm print, the shape of your hand is unique to you. The hand geometry, the palm print is the actual lines on your palm. The hand geometry is the shape of your hand. Retina, your face, voice patterns. Sometimes the keystrokes dynamic and signature dynamics. This is where things get confused between whether it's biometrics or whether it's something you do, right? So this is where both techniques overlap. Is your signature a biometric, or is it something that you do? I would say that probably I will leave it out from the biometrics and just put it in the category of something that you do. Same thing with the keystrokes or behavioral thing, right? Because you may change your signature, but you may train yourself to type differently, but I don't think you can change your fingerprints, right? All right, so the biometrics are commonly used nowadays, becoming cheaper, but they have problems as well. Problem is the accuracy. So yes, everybody has a unique fingerprints and unique face, but the systems that recognizes these fingerprints, they're not fault free, they're not error free. So what happens is they may mix two fingerprints together and they authenticate the wrong person, or they reject the right person. So every system, it has false rejection rate, which is the rate at which the valid subjects are rejected, even though they are the actual person, or false acceptance rate, where they accept the person even though they are the wrong one, right? So usually the biometrics or the recognition systems, what they do, let's say fingerprints, they don't compare every line to every line. They take certain readings from the fingerprints. Same thing with the face recognition. They take certain numbers from the face, the distance between your eyes, the ratio of the length and width of your face, certain numbers, and they store these numbers, right? So, and on the assumption that they are unique to every person. But there is certain probability, even low, that two people will match the same numbers, that are stored, even though they have maybe different faces or slightly similar, maybe brothers, right? So, so there are certain error rate. A certain error rate can be dangerous because it may reject people who are legitimate, or it may accept people who are wrong. There is also certain comprehension against using biometric measurements, because this is something private. right? So you don't want your fingerprints going everywhere, stored everywhere. These are something that can be, it's private to you, and it may be used by the wrong people for wrong purposes. Right? And there can be objection. There are things that are people object to, right? So you don't want, as I said, you don't want my DNA. Well, I don't want my DNA to be stored in some kind of database. Um, it may leak. It may be used in the wrong way. So people have issues with accepting use of biometrics. And also, these systems take time. A password, we can compare passwords to thousands of other passwords in a matter of mm, like fraction of time, milliseconds. But biometrics, comparing your voice to a database of other voices, takes a long time. So the reaction time may be slow compared to other systems, so you cannot use them widely as any other authentication systems. You may use them only for highly secure areas or only at certain times because they take a long time to um, uh, the system takes a long time to react. All right, so there are advantages and disadvantages for of biometrics. The advantages: you don't need to carry anything, you don't need to remember anything, and you need to be physically there, so you cannot do things remotely, and nobody can fake your presence, right? So you have to be there. Um, the disadvantages is that sometimes the physical characteristic change. If you are injured and you have a cut on your finger, you won't be able to use your fingerprints anymore, or at least until you heal. Um, Disabled users, if they happen to be like, let's say somebody who cannot speak, well, they cannot use voice recognition, for example. Um, Not all techniques are equally effective or they have the same rate of success. We talked about response time may be too slow for some systems, and the systems usually more expensive, right? The systems that do these things will be more. A retina scan is not something that you can easily buy and use anywhere. So, and finally, there are the privacy concern of people. All right. As I said before, there are other authentication methods, authentication by location, which require, for example, the location of the user by GPS, for example. So you have to be physically there, or it could be something that you push a button in front of the door, like so. Pushing the button cannot physically, analog button cannot be done from away. So you have to be there. Actions. This, as I said, sometimes these are may be confused by biometrics. So the way you talk, the way you type um, in the keyboard, that's unique to people and hard to recognize or hard to imitate. So it can be used for authentication. But imagine this is a little bit difficult also to use, right? So what are the systems that will detect the way you type? That's a little bit hard as well to implement, but you can. All right. So in all these systems, you need to authenticate every time you want to use an application or a resource. Right. So you want to go to resource A, you want to authenticate, you put your username and password or username and token and whatever technique we used. Right. So all of these are repetitive. Right. Biometrics probably one of the reasons that um, we need to use because we can always provide our fingerprints for multiple systems, it's easy to do. But if you are trying to log into 5 different applications a day and each one of them is a username and password, that's a tedious task. And also, if you use the same password and the same username, this means that if somebody cracks a password, then it cracks and be able to use all of your or access all of your applications and all of your resources. So we need to avoid this, make it easy for people to log in once for all the systems that they need to use. And the trade-off is, okay, we make the login process a little bit harder, but instead of logging in multiple times, you log in once. So maybe just one time in the morning, you log in, you provide your username and you provide your token number or whatever authentication method, and then that will be it for the rest of the day. You access all your systems. So that's what we mean by the single sign-on. So we'll talk about the single sign-on. Okay, so single sign-ons allow users to log in once, as I mentioned. That reduces the human errors, enhances system integrity, security, because you may put more resources in the authentication because you are doing it only once. So you can make the password stronger, or you can make more elaborate authentication techniques, multi-factor, for example, or two-factor authentication instead of one. So you can put a lot of effort in authentication, hoping that you do it only once and you don't have to do it multiple times. So you can invest more in the authentication process. You can also implement stronger enforcement. For example, okay, somebody tries three times to log in and then fails, then they kicked out or they lock out from the system. And it provides centralized administration. So instead of every system or resource or asset has its own authentication system, we can centralize everything in a single sign-on. Right? Disadvantage is, of course, centralized. Any centralized system, if it's compromised, then you compromise everything, right? So you break into the single sign-on, you break to every resources. If you use just simple static passwords, that's too weak. So you usually with a single sign-on you want to use two-factor or multi-factor authentication. One of the disadvantage of SSOs is that legacy systems are not compatible. Something that you have from years ago, it's probably would not be able to use the single sign-on. There are multiple examples of single sign-on. Common ones are enterprise single sign-on. So you go to the university and log in once, and once you log in, you can access all the resources once. You don't have to log in into on every application. So you use your access only once. A web single sign-on, so user logs into a website, and then every other website within the same domain, within the same or trust relationship, use the same login, so you don't have to repeat the login to different websites. You can also extend the same idea to federated single sign-ons, where it may be different domains, different organizations, but they have a trust relationships within each other. So you log into one website in one domain, and then you can log into every other. You can see it sometimes. You log in, use the same credentials for Gmail to different, same as LinkedIn or same as other social media, so or other online applications. It's probably slightly different, but it provides you with the example. Right? All right, so there are common protocols used for single sign-on. Kerberos, if I pronounce this correctly, Sesame, and LDAP. The Kerberos is the one that I'm going to focus on the most. It was developed by the MIT and use symmetric key cryptography, uh, and it has a system called the Key Distribution Center that distribute the keys with users. So I use this as a good example for single sign-on because it provides typical way for users to use the single sign-on. So the process begins by user trying to authenticate. So it sends the credential, username, and password, or any other authentication techniques to authentication server. So the server will take this information and verifies the credentials. I'll show you in the next slide how to verify the credentials, but it verifies that this person is the right one, and it sends or generates a ticket granting ticket TGT to the user. The TGT is then used by the client to request service tickets from the ticket granting server. The TGS is the actual thing that the user uses to log into servers, right? So the client doesn't use the username and password anymore. They present the ticket to the target server, or the resource that they want to access, and then if the server recognizes the ticket, they will use it as authentication. This probably explains things better. So the user step 1 request, this is the first authentication, so it sends username and password to the authentication server. The authentication server, we talked about it here. It sends an encrypted ticket. That represents, think of it as a challenge. Same way we did the challenge before. So the user, because they already have a symmetric key cryptography between it and the system, and they have a shared key, so the user will be able to decrypt the information in the ticket and send it back to the authentication server. The authentication server say, okay, this must be the right user because it was able to decrypt the message. The message is a hash anyway, so the authentication server talks to the ticket granting server and say, well, this user is legitimate. You can issue the TGS to it. So in step 5, it gives you the ticket granting server gives you a secret key, which is the service ticket here, and the user from that point on, it uses this secret key to talk to the server, the actual target, the actual the resource that it wants to access, right? One thing good about Kerberos is that this system here can be local and this can be remote. So if you look at number 6 here, all this traffic, if it goes over the internet, you'll never share your username and password over the internet. Everything goes from now on. The only things that can be seen online is a secret key. just a random number, right? So the username is never exchanged over the internet. And that's one of the advantages of this protocol, right? So preventing passwords from being sent on the internet. And of course, if the user wants to access another servers, they can just ask for more tickets. So they will use different tickets every time they will use. So that's the idea of the single sign-on. So I provided my username and password only once, and then for every other system, I'm just taking a ticket and using it to access other servers or other services. Sesame is similar. I'm not going to go into detail. It's similar in the concept, slightly different in the process. It is created by the European systems. Of course, the Kerberos is created by MIT. MIT is American, so as a challenge, the European created their own system, and this one uses symmetric and asymmetric keys, so public key cryptography and private key cryptography. It's not as popular, so we're just going to move on. Lightweight Directory Access Protocol, or LDAP, is open source, open protocol for distributed directory services. It's not particularly for single sign-on. It doesn't it by itself is not a single sign-on protocol, but it can be used by single sign-on solutions to manage users, right? So it's the idea is to manage the usernames and passwords, right, and access rights for users. So these are the three examples of protocols that we can use for single sign-on. Smart card is another example of single sign-on. You can use the card everywhere. You don't have to use username and password every time you log in, so you can move around and use your smart card to access different systems. All right, if you still remember, we talked about 4 parts in access controls. The first is authorization, the second is identification, the third is authentication, and the last and the fourth part is accountability. Accountability refers to the ability to tracing the user's action, right? So that when they make change, so if they view, you log in the view. If you edit, you log in the edit. So in this case, we can enforce rules. We can enforce accountability. We can make sure that people are responsible for what they are doing, not just because they are authorized to do something, they can do it without anybody checking on them. So, and a lot of regulations and standards require auditing, require that you provide the audit, so that accountability and logging helps with that as well. So you go and look at the log files and see who did what, and you'll be able to trace and verify that the actions were legitimate and authorized. Right? So next we're going to talk about access control models. This is mostly for authorization. We talked about authorization as something that has to be done by the organization. Right? So there are a few definitions that we need to be aware of. Sometimes we use the term permissions or access rights, and this refers to access granted for an object, for an asset or resource, and what can be done with it, right? Examples: read only, edit, execute, delete, and so on, right? Rights refer to the ability to take an action. It's a little bit confusing here. So access rights and rights. So access rights are the permissions. The rights are the actual actions taken by the object, taken on the object by the subject, right? So examples, modifying a system or restoring backup data, that's an actual action. When we talk about privileges, we talk about the combination of the two, right? So you need to. So these are definitions of terms that are being used in different operating systems and different information systems. So administrators have full privileges. Sometimes we call full privileges, which means that they have full rights and permissions on a computer, that they can do reading, writing, editing, deleting, executing, you name it. Not all privileges have to be full privileges, they can be limited, right? So you can have a user that has limited privileges, so not all privileges are full privileges. Okay, when we talk about authorizations, we have certain mechanisms that we use to define authorization, and certain concept as well. So implicit deny is something that you hear all the time, and we can look at it later. So the principle, the idea behind implicit deny is that you have to have explicit rights or permissions to do something. Otherwise, it's denied by default, right? So if you say, okay, do I need to access, do I have the right or permissions to access this file? Well, unless you are given explicit permission to access that file, you are automatically denied, right? So that's a concept in authorization. Everything is denied by default. Another concept is access control matrix, which is a table that includes the subject, objects, and assigned privileges. So the best thing to do is here explained by an example. So let's say in a system, I have these users as rows, and I can say, well, there are different ways to represent this, so I'm just going to pick one. So I have user A, user B, and so on. And I have resource or asset 1, asset 2. So you can say, well, the user A can read and write and execute this asset, but it can read and write only this one. This user can do read only, right? And here read and write. So you can create a matrix like this. You can also represent this matrix in different forms. So this is one way to represent it. So every time a user wants to access a certain resource, the system will just check this matrix and see if they have the rights and the permissions or privileges to access. You notice that I'm using all the terms, right? Because they are kind of overlapping. Capability tables focus on subjects such as users, groups, or roles instead of objects. What I mean by that is the system will say, well, this user can do this. Instead of specifying the actual objects, we'll just say this user can write in any file. This user or this subject can read any file. So it focuses more on the subjects rather than specifying the objects. Um, Something we see all the time, constrained interface, right? So imagine an accounting application, right? Something that accountants use to a database for employees and their salaries and paychecks and all of that. The application itself may represent its interface differently to different users. So maybe a regular accounting person will see something like view, print, something like that. So they click on view, uh, they see a database of employees with their information. But that's it. The same application, if it's accessed by um, a manager who has more authority, it may represent also something called edit. So the interface has, and it will enable the manager to edit some fields in the database, so they can go and edit the salary field, for example, right? So the interface itself, provides a different options depending on the authorization level of the user. So that's what we call constrained interface. Something that probably any network person is familiar with if they access, let's say, a Cisco router, that if you log into the Cisco router, there are two modes. When you do enable, you go to the configuration mode, or you go to you will be able to change the configuration, right? So that's a form of a restricted interface. You can allow users to log into a router, but they cannot go to enable mode. So there is a separate password for the enable mode. If they don't have that password, they cannot go to the enable mode. So that's something that I just thought about. Maybe a good example or familiar example to a constrained interface. There is also something called content dependent control, right? So restrict access to data based on the content within an object. An example of that will be, um, let's say you are going back to the same database here, right? And the database has um, employees from different departments. So name and departments, right? And the department will be department accounting, will be department, let's say accounting, IT, IT, and different departments, right? And the manager who is able to log in, they may see the salaries of if the manager is the manager of the IT department, they may see the information of the IT employees, but the salary of the accounting employees will be blank, right? Nothing shows up, right? So because this person who logged into this application is the manager of the IT department, but they don't have access, or they shouldn't have access to the accounting department salaries. They see only their own employee salary. So this is an example of content dependent control. Another concept in authorization called need to know. This principle ensures that subjects are granted access only to what they need to know. Right? You see sometimes, okay, so uh, um, you have, and I will explain this later when we talk about mandatory access controls. All right, so you have certain access, you have certain clearance to access files, right, at certain level. But that doesn't mean that you go, because you have this clearance, you go and read every file that has that that you can, right? You may be restricted only to access the files that you need for a certain project or for a certain report that you are trying to uh, write, or for a certain research that you are conducting. The only things that you access only the files that you need or the information that you need, and not just blank permission to do anything, to look at everything. Another concept is least privilege, similar to need to know, but also includes the right to take action on a system. So you may also um, be able to do things that change things, for example, but only um, for a certain purpose. Another concept is called separation of duties and responsibilities. All right. Um, I'll use the accounting again as an example. Let's say um, just because you are in an accounting department doesn't mean that you can do anything you want with the salaries and with the paychecks, right? So, in order to make sure that people don't abuse their privileges, usually we separate the work among multiple people. It's less likely for multiple people to, do think harmful. Right? So, so the task is split among multiple people. Each one does part of the job, but not the complete job, right? And then hand it over to somebody else who completes the job. So nobody has control over the whole process, right? And this way, we make sure that nobody abusing their authority or doing something that they're not supposed to be doing. So all of these concepts. Um, then we move to something called the access control models. So we have multiple models. Each one of them, you are familiar with a lot of them. Um, they are common. Um, so there are here in this slide there are five. I think they cover everything here. So the discretionary access control, or DAC, mandatory access control, rule based and role based. You have to know the difference here: rule based and role based, and then the attribute based. The top one is discretionary, and the other four are put under the umbrella of non-discretionary access controls, right? So sometimes you see in the documentation something called NDAC, or non-discretionary. These four belong to this category. Okay, so let's jump into these models. These models, as I said, you are familiar with them. They are implemented usually in operating system. So we'll use operating system as an example. If you are familiar with operating system like Linux and Windows, you're probably familiar with some of these, or will use these operating system as examples. So, discretionary access control. In this system, the access for a resource is based on the discretion of the resource owner, right? So what does that mean? If I create a file, I am the one who is responsible and able to give permission to other people to use the file. And you see it in Windows, for example. You can go to any file or directory or folder, and you just um, create permissions for other users. So you can say you are able, or this user is able to modify or read and execute, list folder content. You can either allow or deny different things, right? In Linux, there are actually permissions, three types or level of permissions. The first, if you do a list of the files in a folder, you will see that each file is preceded by dashes or letters. The first group of letters is represents the permission of the owner. So the owner in this case can read, write, or execute the file. Execute means run, or if it's a folder means look at the content of the folder. So these are the rights. The next group refers, or the next group of characters refer to group permissions. So I can assign a group of users permissions to read this file or write or execute. In this case, I gave, or the user gave a permission to a certain group to read the files only. I can change these to read, write, and execute, or write only, or even though it's probably not practical, but anyway. The last group of characters refer to everybody else, right? So everybody else can read this file, or sometimes if it's dash 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 means that they cannot see it, right? So the owner, who sets this? The owner or the administrator, because the administrator have higher privileges, so they can do everything. But the owner of the file can assign privileges for other people, other groups to access this file, and for everybody else. Right? So this is where the word discretionary came from, right? So it's at the discretion of the resource owner. Most of the operating systems apply this system, this access control. So I already showed you Windows and Linux. Mac is the same. We can also control these things using access control lists. So the access control list can say, well, if this is user X, you can do this and do that. So it provides, although the access control list can be used for finer control. Okay, so there are also something called application-based discretionary access control, where the access is based on the user privileges. This is similar to what I showed you, the restricted interface example, right? So the restricted interface example, it shows different menus and different options based on who the user is and what authorization they have, right? So content dependent, context dependent, all are different types of restricted interfaces and also belong to the category of application-based discretionary access control. Right. So there is an overlap in the idea here. Okay, so permission levels. You can have permission levels based on users. So the permissions that are given, read, write, execute, whatever, delete, given to a specific user. As I said earlier, granting user by user permissions is a tedious job if you have hundreds of users in your organization. So you can also create permissions based on groups, and in Linux you can do that by assigning different groups in the operating system, and then each group can be granted access. You can also assign access based on job. If the person is working for the accounting department, well, they have access to database that contains salaries, or they have access to purchase or financial information in general, not necessarily salaries, but financial information in general. If you are in IT, you have no business looking at the financial information for the company. So that's you can also do it based on project. So a group of people working on an IT project, and while they're working on that IT project, they have permissions to access certain resources belong to the project, but they don't have access to anything else. Or sometimes based on task. The accounting at the end of the week, at the end of the month, they want to issue paychecks to employees. So within the last week of the month, they have permissions to access databases that belongs the salary databases. Outside of that week, they cannot do it, right? So it's kind of limited in time and limited in task, right? All right, so the non-discretionary access control is an umbrella that includes many other models. Generally speaking, this is not or in this case, the owner of the resource is not the one who determines the permissions, right? So that's the main difference between the discretionary and the non-discretionary. In this case, the administrator, it's either security administrator or IT administrator or somebody with an authority, is the one who decides who sees what and who access what, right? Um, this is more secure because um, you can have more control concentrated in one or a small group of people rather than trust everybody to do the right thing, right? So all users. And also, it requires less knowledge, less technical knowledge of users. In this case, how many users are actually know how to change these things, or how many users know how to change, or how many Windows users know how to make changes? Not many, right? So you need, if you want to use the discretionary access control model, you want people to know what they are doing. A lot of people probably don't know. They are regular users, they don't know these details. So it will be hard for organization to trust that all users in the organization will be able to do these things. So rather than that, this job is allocated to the administrators. And the administrator will be easy for them to comply with the organizational policies, right? Um, The administrators also have resources or have access to resources that other users should not be able to access. In this case, like for example, changing the system clock, right? Or certain configuration files. So if the administrators have access to these, only administrators have access to these, then probably will make systems more secure. And sometimes these two systems work together, so it's not like either one or the other. You can see in some organizations, for example, they will hand you over a laptop, right? You can use the laptop. You can read files, write file, create Word documents, Excel documents. You do a lot of things, but you cannot, for example, install a new app on your laptop. You have to take it to the IT department who can install things if you need to, right? So there is a mix in between. So organizations can use a mix of these um, discretionary and non-discretionary access controls. So it's not either one or the other. Right? All right, so let's take examples of the different access control mechanisms or models. So in the mandatory one, the level of restriction is determined by how sensitive the resource is. And usually the data, when it's generated, it given a classification table. Right? And you can see this in the movies, in the media, or sometimes in the news. You see that top uh, the document is labeled as top secret or for your eyes only or um, restricted, right? So or classified, or these are labels that are given to a resource, a file, a document, whatever, and that label identify how sensitive the information is, right? Then the individuals, they can get a clearance level. So clearance level 1, you are allowed to see a certain level of documents, but not maybe classified, but not top secret, right? So the more clearance, the higher clearance level you have, the more secret or the more sensitive information you can see. This can be at the organization level, it can be at government level, so it really depends on every organization may have a different classification system. We see in the media the classification level of governments, right? And that's combined with the need to know element, right? So as I said, if you have a clearance level, that doesn't mean any classified document you can read it. No, it has to be you are allowed to read only the things that related to your job or related to something that you are trying to do at some point, right? So clearance level does not give you the right to go access everything. Um, some of the techniques that used to restrict access is either temporal or task related. I mentioned these before. Temporal isolation means that the access can be done at specific times, right? So you classify the file, classify the object, you give it a label, and then that file can be accessed only at certain times and only by the people who have certain clearance level. And you can see if you read the slide, you see the mention of role based. So you see sometimes an overlap, right? An overlap between multiple elements. As I said, it's not like a clear cut. You either do this or do that. Sometimes there are multiple things. So you have to be at certain role, you have to be CEO or COO or C-level um, um, person in the organization to be able to see the financial statement of the organization. So, okay, so that's both the both role based, and also you have a clearance level to see a document that is supposed to be a sensitive document. Not everybody can see it, right? So, uh, okay, rule based. This is something that a lot of people are familiar with. This is simple access control list. So, access control list is says, well, if X, then Y. If this person wants to access this document, then allow based on conditions. The conditions can be based on identity, can be based on time, can be based on clearance. You can see here that we are actually mixing things. So, and so far we talked about users, and sometimes I mentioned process, but we can use access list also at the level of packets. We can say, well, if this packet matches this criteria, then allow, right? So it's another form of packet. In this case, is a subject that wants to access a resource, which is a network, right? And you can say, well, if or a certain destination in the network. So if this packet had matched this criteria, source, destination, TCP port, etc., etc., it can go and reach that destination. So rule-based is very common uh, access control mechanism. And you can see it here, you can implement it also, you can use it. I mentioned already that it can be used in discretionary. The difference is who creates it, right? So if it's created by the owner, then it's a discretionary. If it's created by administration authority, it's non-discretionary. So you can so this person here um, has full control of his own directory, but he can write to Kevin and can doesn't have any access to Kira, and also can execute something on the printer. So the administrator creates this access list and gives permission to different people. Right. All right. Role-based refers to the model where you give access or grant access to resources based on the job description or based on the role of the user rather than based on the actual individual identity of the user. So if you can say, well, the example that I gave is, all right, any financial documents can be seen by the CFO, Chief Financial Officer, right? Um, Regardless of how sensitive the information is, right? You can also say, well, any developer can um, access the organization Git repository, right? So that's a role-based access. The role-based access has the advantage that the administrator who grants these access they don't have to bother with the actual identity of the users. What they can do is just create rules uh, or create access control mechanism based on the role, based on the job description. So if the CEO changes, well, nothing needs to be changed in the system because there's just a new CEO assumes the same role as the old CEO. If the a new employee comes in to the IT department, there are no need to add anything to the system because the new IT employee has the same role as other IT employees, so they will have the same access control. So that's actually can be considered as group access control as well because you can assign groups, a group of IT, a group of accounting, a group for C-level executives, so you can assign groups this way. Right? And finally, I think this is the last one, is the attribute-based access control. The attribute-based is the most granular. You can imagine that you are mixing all the access models that I talked about in one. So that's what will be the attribute based. You can create very fine-tuned access controls where add you you create policies based on the subject or the user, based on the object or the files, based on the actions, based on context, based on time. So you make a very fine-tuned control, right? Of course, the drawback is that any minor change in the situation, it requires the administrators to go back and change things, right? So it's Jean, who is the CEO, can access this file at this time during business hours in this room, right? You can make things very, very, very specific. But if you want to move the room somewhere else, you have to go and change the access policies. If yeah, so you see what my point is that the more specific, the more difficult to manage. So all of these are the access control models, right? And um, now, of course, imagine if you are doing this for every resource you have, whether it's by one administrator or by group of people. It takes a lot of effort, right? Um, so to avoid having an administrator goes to every server in the organization and implement access controls for all the employees on that particular server, which is, you know, a headache. So we usually rely on centralized access control. So authentication, authorization, identification all happen in one system, centralized system that controls everything, right? So this is where we start talking about centralized access control. Okay, centralized access control has several benefits. Well, first of all, the centralized access control services that we're going to talk about, they are usually used or enforce authentication, authorization, and accounting, and we call them AAA servers, right? So the benefits of AAA servers include less administration time, because everything is centralized in one location rather than administrators going into different servers, different applications, different resources. Reduces the errors, of course. Less training, because you have only one system that you need to train on. Easy to control any compliance with regulations and security standards, and um, centralizes any help desk or any support that you need, right? So everything in one location. And of course, as with anything else centralized, it provides a single, or it is a single point of failure if something happens. There are we're going to talk about three types of AAA servers: Radius, TechX Plus, and Diameter. The oldest is Radius, and it stands for Remote Authentication Dial-In User Service. From the name, you can probably guess it was used by service providers in the days of dial-in or dial-up services, where the user sitting at home dials in the ISP. The first thing it does, the ISP, is to, of course, the ISP either grants them permission to connect to the internet or not, based on whether they are customers or not, and based on whether they have an active account or not, right? So, and you can use Radius for an organization to use the same principle to allow users, employees, to access resources within the company. So you can use the same server, right? But it has its roots in the ISP business, right? So, and you can see that from the Radius operation. So a remote user tries to log in or tries to have a connection to the internet, so they dial in. And at the other side, there's the network access server. The network access server will take their credentials, username and password, and forward these credentials to the authentication server, or the Radius server, right? The Radius server in this case checks the credentials against the database and either accepts or rejects the connection. Then, as based on the decision, it allows the remote user to log in or to get access to the resources. Uh, so that's the simple Radius operation, right? Um, as a as an improvement to Radius comes TechX Plus. There is TechX, which is a proprietary protocol. TechX Plus is an open standard, right? So that's the difference. Um, there are it improves upon Radius by using TCP as a protocol, while Radius uses UDP. Also, there are few other differences. Radius encrypts the user's password only as being transmitted from the Radius client to the Radius server, right? So only this part here, this is the Radius client, which is the NAS, and this is the Radius server. So the username and password is encrypted in this link, right? Um, Other information, as in um, the accounting, authorized services, etc., is passed as clear text. So the only thing that is being encrypted is the password. I hope I said the password the first time, not the username and password. But anyway, the only thing that is being encrypted is the password. Everything else is being is being sent as clear text. TACACS Plus, on the other hand, encrypts all this data. So all the connection between the NAS and the back-end server is encrypted. The Radius protocol combines authentication, authorization, and functionality, right? So basically, you combine how to authenticate the user and also what the user can do in one function. TACACS Plus separates the authentication, authorization, and accounting functionalities, and that means that you can actually have multiple uh, types of users logging in, right? Not just one type of users. In Radius, I think because of historical reasons, all people who come in they're just going to the internet, so they have the same authorization level, right? But if you want to separate, if you want to use granular control, some users can have access to these resources, others they have access to these resources. So you need to separate the functionality. So authentication is one thing, making sure that this is a legitimate user is one thing, right? And also what they can do is a different thing, right? So here you can see similar technique. Somebody dials in. There is the TACACS Plus client, which is similar to the NAS in the Radius, and the TACACS Plus server, which is similar to the Radius server. The user initiates PPP authentication. PPP is a protocol, point-to-point protocol. At, uh, Initiate PP authentication to NAS. Part of the PPP, which we'll talk about later, is a protocol dedicated for checking the credentials. It's either PAP or CHAB. These are two different protocols. We'll talk about them later, but anyway, the NAS uses these protocols to ask for credentials. The users provide the credentials. So step 4, the TACACS Plus client sends these credentials to the server. The server either grants access or not based on whether the user is actually in the database or not. And then things continue. All right, so that's the simple operation. They are similar in many ways. The third type of server here, AAA server, is Diameter. Diameter is a playing on word for radius, so it's not an acronym. It's just radius is double the length of diameter is double the length of radius. So that's where the name come from. It has two parts: base protocol and extensions. Extensions are used. The base protocol is for the communication and feature discovery and version negotiation and things like that. And the extensions are for different types of authentication authorization. Diameter has a different functionality as well. So all of those are centralized servers, right? But Diameter actually allows you to do peer-to-peer authentication as well. So it's not, you can use it as centralized server, but you can also use it in a peer-to-peer fashion where users can grant each other permissions. So that's another difference between diameter and radius. Diameter also uses UDP, like radius. Okay, so radius or diameter operation works this way. The user sends their credentials to the NAS, and the NAS forwards the credential to the diameter server, which is in this case we call it agent. The diameter agent routes the request to the appropriate diameter server, which is the diameter application. So now we have three pieces, right? And the diameter application checks the credential against database and then grants or rejects the permission. And the agent relays the answer back to the NAS, which is also responds to the user. So you can see here there are more parts in this than the first two, because we have client, we have, and this is the client, this is not the user. So the user talks to the NAS. The NAS from the prospective diameter is the client, and then we have an agent, and then we have an application, right? There are four pieces here. All right, all of these are centralized access control mechanisms. What about decentralized access control? All right, so decentralized access controls involve handling access decisions and administration locally by department managers or system or system users, or somebody who's close to the system users. As with any centralized mechanism, there is always the risk of single point failure and bringing the whole system down because you cannot access anything if there's a failure. So you want decentralized access control. Decentralized access control, however, has the disadvantage of being under different administrators, and that could lead to inconsistencies, loss of common standards in granting access, maybe overlapping rights or gaps in rights actually. So it's not always preferred, but it has its advantages. There are protocols that can be used for decentralized access control, and funny enough, we saw some of them being used as part of centralized access control. So I mentioned here PAP, PAP, or CHAP. So by themselves, they can be used as example of decentralized access controls protocols. You can see them here: password authentication protocol and challenge handshake authentication protocol. There are also open authentication standards, or OAuth, which is a set of standards, not just one, but a set of standards that are designed to provide authentication. Some of these standards, they are part of the tokens that we talked about earlier, or they can be used to implement the tokens. So one-time password, HMAC based one-time password, or HOTP algorithm, that's something similar, not necessarily the same, to the tokens that we saw earlier. The growth of web-based applications has led to distributed and decentralized systems. Of course, if you have multiple websites all over the place and different locations and different um, different systems and different organizations, probably centralizing access to those will be not practical. Right? So, uh, so that's what led to maybe trying to have a decentralized access control. One thing that it is supposed to be in this lecture, but we'll postpone it to another lecture, which is identity and access management, is another very important subject by itself, and it's supposed maybe it could be here, but we're going to postpone talking about this to another lecture when we talk about security systems. So the identity and access management play a very significant role in access controls as well. All right, so let's talk about some of these protocols, and we won't go into deep details here. These are very well documented protocols, and there are so many resources that talks about these, so we just need to be aware of the main characteristics of these protocols, and that goes for all the protocols that we talked about today. Right. So point-to-point protocol is an old standard that encapsulates IP uh, over or in a point-to-point links, so it encapsulates IP packets. PPP also, like DHCP, grants IP addresses. I'll give you a quick look at what I mean by that. So, as I said earlier, in the dial-up days, the remote user wants to connect to the internet, so it sends a or it connects with a dial-up modem to the NAS. At this point, the 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 user doesn't this computer, the remote user doesn't have any IP address, or it has an IP address that's local. So one of the things that it needs to do to be able to connect to the network is to get an IP address. So PPP assigns an IP address uh, to uh, to the remote users, right? And also deals with link configuration, different link configuration. Compression techniques were used because bandwidth was limited, and all of these things, right? PPP is actually an umbrella protocol that has separate protocols underneath it. One of them, so I'm going to continue talking about uh, it relies on link control protocol and NCP's network control protocols to negotiate optional configuration parameters. So what happened is um, the user actually uses these protocols first, and then PPP is used um, uh, to encapsulate, as I said earlier. Um, all right. So after the link is established, PPP has optional authentication phase using PAP and CHAP. So again, these are the ones that I mentioned earlier, here and previously. Uh, uh, so this is a sub-protocol under PPP, like PAP and CHAP is some sub-protocols under PPP, and the 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 PPP relies on these two to provide authentication. PAP is simple. Does a simple thing, which is just ask for username and password, and they are sent as a clear text, right? So in these days, you are just sending traffic on this link as clear text, assuming that nobody else can reach this connection. Um, and it's used mainly for this purpose, for users to dial in, right? Obviously, if you are using a different scenario, if this is in a network where other people can reach over the same LAN, then probably clear text username and password is a bad idea. So and PAP is using the username and password only once. Once you log in, you log in. That's it. CHAP came, if I remember correctly, it was created by Microsoft, and it improves the situation by actually continuously challenging the user. So it's not just one-time login. The actual user, does one-time login, but between I go back to this between the NAS and the computer, this picture here better, right? Between these two, the NAS keeps sending a challenge. A challenge, as I mentioned before, is a random number that sends, okay, and if you are the actual user, send me back that random challenge encrypted, or if I sent you encrypted challenge, send it back to me unencrypted. So it keeps sending the challenge and waiting for the response. As long as the responses are okay as expected, then this is the actual user and no problem. If somebody tried to hijack the session and replace the user, of course they will fail the challenge, so the challenge will fail and the remote user will be kicked out. So that was the CHAP purpose. So that's what here says. The CHAP is performed at initial link establishment, and it can be repeated anytime after the link has been established, so it keeps repeating periodically. Okay, so more detail. After link establishment, the authenticator sends a challenge message to the peer. The challenge consists of identifier, a random number, and either a host name of the local service or the name of the user. Right? The receiving peer calculates the hash value using one-way hash function and secret key. So that's the two sides have to use a secret key to communicate. And in this case, we are using hash rather than encryption. Similar idea. So the peer sends a challenge response, and of course, because of if you are using the same hash algorithm both sides and you have the same shared secret, so what happens is, let me explain this. This is another technique. We talked about it in the encryption course. So here is the idea. There is a client and server. The server sends, say, okay, here's a number or a sequence of number or a different, it says random number plus ID plus other information, so it doesn't matter, right? So let's say just a random number and ID. Okay, so the client, they have a key, shared key between them, secret key. So the client, instead of encryption, it does hash. So it hashes the R plus the ID plus the key, concatenate the strings, and creates the hash and sends the hash to the server. Now, the server cannot get the hash back, right? So once you create a hash, it's a one-way function. You cannot get the content back. But the server can also do the hash itself using the same hash function. These two should be equal, right? The hash that came from the client plus the hash that was calculated locally. If the numbers or the content match, then the hash will match, right? So that's another way to send a challenge and response. OAuth standard, OAuth is for open authentication. There are and sometimes they are a set of standards. There are a couple of them, or more than a couple. There are 4 or 5 of them. They're not same as OAuth, probably is pronounced similar. This is an open standard for authorization. This is for authentication, so there is a difference, right? And all right, let's look at the OAuth standards. So there is the HMAC-based one-time password algorithm. The standard defines a way to generate one-time passwords based on secret key and a counter value. Remember we talked about, synchronized tokens, and one is based on event and one based on time. So this is based on counter, based on event. So you increase the counter, you generate one password, and that's it, right? One-time password. And it's defined by RFC 4226. TOTP is time-based one-time password algorithm. This extends this event, the first one, by using a time value instead of counter. So this is good for time synchronized tokens that we talked about earlier, right? And then we have OCRA, which is a challenge response algorithm. This standard defines a way to generate challenge response pairs based on secret key and various parameters such as time, counter, session, or transaction data. Challenge response pairs can be used for authentication in situations where the user needs to prove their identity or authorize an action. So they can do something like this. They standardize this operation here, right? So this protocol actually standardizes this operation because this is challenge response. And then we have something called portable symmetric key container. Defines a format for storing and transporting symmetric keys, such as those used for OTP or challenge response algorithm. So this one is actually part of these three, or these three can use this one. The portable symmetric key, right? Finally, a dynamic symmetric key provisioning protocol. This standard defines a protocol for securely provisioning symmetric keys to devices or applications over an insecure channel, right? It allows for dynamic creation and distribution of keys without requiring pre-shared secrets or certificates. If you remember back when in the cryptography course, we talked about Diffie-Hellman algorithm, right? Where you can create a secret key without actually sharing any secrets. So this could be a way to do this as well. Each one of this is an open standard. It has an RFC that defines it, and they overlap, right? So they use each other. So one RFC uses the other to fill part of the operation. The open authorization standard is this is a standard for access delegation. It's commonly used as a way for internet users to grant website or application access to their information on other websites, but without giving them the password. So you want an application to access a website, you give that application the authority without actually require the application to send user a password, right? Designed specifically to work with HTTP. And I think if you encounter something like tokens, so most likely the tokens using the OAuth standard. So applications, when they access a resource, you don't expect them to provide username and password, right? So instead, they provide tokens, and one way to provide tokens is this standard. And the standard focuses on authorization rather than authentication. So authorization, remember, is um, specifies what users or applications in this case what they can do rather than focuses on who they are. And that brings us to the end of this presentation. Um, Hopefully, that covers all of the aspects of um, access controls. We still need to talk about identity management systems in other lectures, but that covers the whole subject of access controls. And we'll see this access control uh, pops up in other topics as well because it's a fundamental concept in network security. So, with that being said, thank you for listening, and we'll meet in another lecture.